First of all, what is a hologram? A hologram is a three-dimensional image formed by the interference of light beams from a laser or other coherent light source. Now, there are many different things that are often misunderstood with being a hologram. These include effects produced by the Pepper's ghost illusion, lenticular printing, also known as motion cards, tomography, and volumetric display. Holography dates back to 1947 when scientist Dennis Gabor developed the theory of holography while working to improve the resolution of an electron microscope, though further development in the field was delayed during the next decade because light sources available at the time were not truly coherent. This was overcome in 1960 by scientists Basov, Prokhorov, and Charles Townes with the invention of the laser, whose pure intense light was ideal for making holograms. In 1962, Emmett Leith and Jerzy Patniks realized from their work that holography could be used as a 3D visual. They read Gabor's paper and decided to duplicate Gabor's technique using a laser. The result was the first laser transmission hologram of 3D objects. These holograms produce images with clarity and realistic depth, but required laser light to view the holographic image. Their work pioneered the standardization of equipment used to make holograms today. Also, in 1962, Dr. Yuri Denisyuk combined holography with natural color photography. This produced a white light reflection hologram, for which the first time could be viewed under light from an incandescent light bulb. In 1968, Dr. Stephen Benton invented white light transmission holography. This type of hologram can be viewed in ordinary white light, creating a rainbow image from the 7 colors which make up white light. And in 1972, Lloyd Cross developed the integral hologram by combining white light transmission holography with conventional cinematography to produce moving 3-dimensional images. Now, holograms can be recorded and later reconstructed when the original light is no longer present, due to the absence of the original object. They are recorded using a flash of light that illuminates a scene and then imprints on a recording medium, much in the way like a photograph is recorded. With the science of optics, the issue of counterfeit money can now become closer to being resolved. Security holograms are very difficult to forge because they are replicated from a master hologram that requires expensive, specialized, and technologically advanced equipment. These security holograms are now being implemented in many currencies around the world, including the currently circulating banknotes of the Canadian dollar. Counterfeit banknotes are now a lot more easily recognizable. A holographic storage that resembles a CD is being developed, and it allows it to store potentially over 100 times the amount of storage of a regular CD. Environmentally, less resources are needed to acquire the same amount of storage. Also, less e-waste is being produced because the amount of CDs needed is being reduced. The arrival of the first prototypical optical computer, which uses holograms as storage material for data, will be able to deliver trillions of bits of information faster than the current generation of computers, resulting in a higher performance. Socially, this will benefit a lot of people due to our attachment to technology.